Yeah, okay, we can start. So, welcome to the NGSR Meetups featuring with Michael Hladky. Get ready to dive into performance at scale, non-trivial optimization techniques in Angular. With Michael, a Google developer expert, also Microsoft MVP, learn the secrets of scalable architectures and high performance processes. So, you can start, Michael. Yeah.
Thanks for the nice introduction. I will share my screen. Okay, you should see my screen now. Is it correct?
Yeah.
Oh, perfect. Okay, let's start with my talk on web performance and the latest Core Web Vitals. And I will really want to start on why we should care about it. I often have discussions. Michael, can you explain to me how we should budget that in? What is the value of performance? Why do we even care about it? What value do we get out if that numbers improve? And I will boil it down with a completely different approach because normally people pull out these old researches or up-to-date researches where I say this and that milliseconds improve this and that revenue in Amazon or that statistics, and I will give you a different one. If a user, and there is even a metrics, the metrics is called rage click, is so unsatisfied with a product that he is getting in rage, right? To not be able to interact with your product properly, then this is a bad sign, and rage normally leads to like dropping off the product, not using the product that often, and in the end, that is losing customers. And if you tell me what worth is not a millisecond but a customer, it is way easier to nail it down. What does it bring to focus on that topic? Besides all the latest updates that we will also run through. So there's also a technical drive, but this is more my motivational background, how I see why they should care about performance. So we should care about that. And over the years, it was pretty hard to standardize that. It was a long process, and we more and more land on a spot where we say the most important stuff that we should do is when we measure something, it should be user-centric. And therefore, I grouped our agenda of all the different tricks that I want to show you also by some of those user-centric metrics, and those are the core web vitals. So I have a couple of examples for CLS, a couple of examples for LCP, and then we will also improve the new metrics INP. And I thought there are a lot of common techniques out there, so I picked for this talk here only the ones that are edge cases, are not so easy to implement, or that need a little bit of understanding to do it right. Let me quickly introduce myself. My name is Michael Hladky. I'm a trainer and consultant at Pushbest. I'm on X, active, and tweet a little bit about stuff that I do or other things. I'm very active on GitHub, run a couple of open source projects and libraries, and I also run a company that's called Pushbest, and we focus, as I said, training, consulting, and development in the areas of scalability, like performance, architecture, and NX. But okay, let's start with the first metrics. I will not do a theoretical talk about core web vitals. I will quickly pitch what each metric is, and then I will immediately dive to the beefy part. So CLS, cumulative layout shift, here is a little bit of a timing, how good to improve or poor your current cumulative layout shift is, and that is basically when the page shifts in a specific direction. I have a couple of more details how this is calculated down in the corner of the slide, but I don't want to go into detail of the metrics. It's good enough if you understand if the page jumps, that's bad, and it should jump as little as possible. So when does a page jump and how do you identify that? I give an example. You have some text visible, some very big and interesting information for the user, and then a new content pops in, right? So you need some space, because if this new content would pop in, it would enlarge the scale, and therefore you need to deal with that distance, and you do that by basically reserving some space. But what space you reserve it for? Something important like advertisement. No, not advertisement, maybe something more useful, but this is the funnily enough, the biggest problem that we solve: some ad banners at the top. So what you do normally is you put a loading spinner there and the problem is solved. But what if your reserved space is a font? What if you can not really reserve that because there is already something there, like the font, it is just not styled in the correct way, and therefore it will also jump a little bit. And this is a problem that is most probably not that easy to solve. And the way how you approach it is you use basically a couple of settings that your browser native language that is immediately available looks quite similar to the one that you want to load. And here I brought a tool that you can use online. The technique that we use here is basically called font style matching. And with font style matching, you can avoid this specific edge case, right? Even after you did all the lazy loading and preloading and inlining, this would be one last case that you could have to deal with. And maybe I quickly can show you the tool. You have two different fonts, and you have all these settings that you can change. You can change the font size, you can change spacing and line height. And if you do that correctly, the better you do that, the more inline your fonts gets. And you can check that here. And at some point it will look really good, right? If you have the word spacing correct and everything. And then it will fill up the right amount of space that you will not have a content shift. So that's font style matching, and a little bit of a tool here with a link for later. Let's jump to the next slide and to the next metrics. CLS, largest contentful paint. This is a visual indicator how fast your website feels. And here we have completely different timings. If we had like some very low 0.1 numbers, here we are in a different unit. We have here seconds, and a good metrics would be 2.5 seconds at the moment. Of course, the numbers will get adjusted on a regular, more or less regular basis, but this is what we have at the moment. So what is the largest contentful paint? The largest contentful paint is, in many cases, big text, as I showed you before, or an image or other, let's say, multimedia resource like a video or something like this. And I highlighted here the, the final largest contentful paint element in that screenshot, so that you can see it is only one of those tiles. In many cases, it's the first one. Largest contentful paint, or the loading speed, the visual loading speed, is normally explained as this film strip where the website builds up step by step, and at the end you see the final result. I want to look at it a little bit more technical so that you can understand where you can improve things. And the largest contentful paint broken down in a couple of different steps looks like this. You have on the left the load event. You receive data from the server. You have your time to first byte, and then you process some maybe scripts, other things, or just the content, and then you render and paint that. While this processing time here in the middle could change quite some things, right? First you have the font, then the image pops in. In this phase of processing and rendering, you can have candidates. You could have first the text, that is the largest contentful paint, but a little bit later you have the image. So you know only after your page is fully loaded what of all of the candidates the real largest contentful paint element is. But if you understand it in that sections and that way that I described, it helps a lot to understand where to hook in and what to improve. I want to go one step further, because concepts are most important if you want to improve something. The better you understand your data, the better you can like put the keyboard on a specific place and code and improve just the thing that has the biggest impact and not losing time on other stuff. And one thing that you can use, or one tool that I really want to suggest you should use when you work with the largest contentful paint, is the breakdown chart of the largest contentful paint in 4 different areas. On the very right, you have the left, you have the time to first byte. This is, as I showed you before, the time it takes until something arrives on your computer, on your machine. Then you have a second step. And in the second step, resource loading delay, things happen that maybe are responsible to delay the loading of the real largest contentful paint resource. Maybe you have to wait for a couple of amount of data to render that. This is phase 3, resource loading time. Resource loading time is showing you only the time that it takes to download the resource, download the image itself. No delay, no data fetching that you need to figure out which image it is, but only the time it takes for the image itself. And in the last section here, in section number 4, element render delay, you can have all potential flaws and issues that appear when you have the resource, but it still takes some time to display it to the user. If you look at section 2 again, it is not a non-trivial thing. Here I also included some scripting time. That means Angular bootstraps. Then the gray box is data fetching. I first need to fetch some data to understand which URLs I have to display, and then another scripting period. This is the last yellow one. So this is really not the basic case, but already one with some data fetching and potential bottlenecks in between. I will share later on the slides. You can use the chart and really draw your own LCP breakdown in that nice charts and maybe use it to plan your improvement. Here the steps again mentioned: server framework, the LCP loading, and the rendering time. I really suggest let's keep that in mind and really use it to dedicate our energy to one specific bottleneck that we have, the biggest one that we can find. And in this here, I want to focus on the resource loading. So the middle part, this is where I want to try to show you a couple of improvements that are maybe not trivial to solve. The first basic one, just to recap, is we have loading techniques. They also work for iframes, and we can lazy load images and iframes. I guess this is a pretty basic information, so I only scratch it to build up a little bit and show you that you can use that manually, but you can also use that with the ng optimized image package in Angular. Lazy loading would then be really automated. So with lazy loading, you save a couple of megabytes, or in some cases even more, when you only load the images that are on screen. Another thing that you can do to prioritize and order the HTTP requests that are sent is you can use fetch priority. Fetch priority is a new feature, and it is pretty cool. Like if you remember the old days where you had to hack in a couple of scripts at the top of your header to always prefetch the specific image, now you can use the fetch priority high tag and it on the element itself, and it will reorganize the priority and fetch your largest contentful paint before everything else. That is a really nice improvement, and that is also able to use with the ng optimized image. Here you see you have a couple of bits of code, and it is set up. All the knowledge from before is automated here, and you can just use it and focus on your task with nearly automatic performance. Pretty cool package in Angular. And one interesting part of it, it also supports responsive images and a couple of other things. And here I want to really focus on responsive images and the source set, because this is quite interesting and tricky sometimes to solve. A little bit of an understanding, this is just plain HTML, and you see a couple of different formats can be used for the same image if a media query hits, if the screen is big enough or small enough for this specific size, then you can use and load that image. It helps a lot when saving some megabytes. When you look at an image on a phone, it is way smaller. You don't need to load that of a big resolution, and on a desktop, it's way bigger. This is also supported by the NG Optimized Image Directive. As you can see here, you just prefix them with NG and the thing should work. The only complex stuff with the source set and responsive images is not to use it in Angular. That is pretty easy, but in general, for pretty much any usage, is setting the right values. And that is non-trivial, I realized, at least for me. So I thought, let's dig a little bit in why this is complicated. I started to read a little bit. I really gave my best, and I ended up in this refactoring when I used source set the first time. And I had a couple of options. I tried it out and I realized, after my measuring, I have now more megabytes loaded than before. And that is obviously not what this technique should do for you. This technique should really save you some bytes, right? So on the left side, you have my first implementation, the wrong implementation, and the marked sizes here is really what I load more. And if you implement it correctly, you can see that I have a lot of opportunity, especially down here, where I nearly save 3/4 of the whole downloaded megabytes. So, why was this complicated? And what I did was just adjusting the numbers correctly, but this was a real pain. And I came up with a snippet. I wrote a small snippet that helps me to debug the different hooks when an image is loaded, at which screen resolution, and so I could fine-tune and work it off. I linked it in the slide. It is open source, a little bit of a description how it works. I will really just scratch the surface here and use it for you, but in the end, it will produce a table where you can understand what breakpoints you have and which image resolutions it was, and if the size was too big or too small for that resolution. I also highlighted stuff. So when it is oversized, it is red. When it is undersized, it is transparent. And here I also show it with a little video. What I do now is I copy that script over, and I basically here already have prepared my Angular Movies app. And in that app, I already used the source image. I just need to find out the right measures and debug it. And I did that. I set up a source snippet here that is called src set. I pasted it, and then later on I opened up my quick sources script so I can have the play button open in the same time as the script execution. So now I have the page open. I will resize that to the very minimum that is possible, like this. I also check, do I have my device pixel ratio set correctly for the test? Here I have it at 2. This is on responsive. What I could also do is I could open up the network tab, and I can also have here bigger symbols and filter for images, and then I could clean that up. Okay. Good. This here is the first load of that image. I will now start the script and go to my console. When I start the script, it prompts me to put a selector for an image. Here I will just put EMG, the first image that is visible is taken, and this is already marked with a red border if you see it already. And if I go here, I now have, let me open that up a little bit. I have a table, and in that table I see my client with at the moment, which image was fetched, how the intrinsic size and the rendered size is, and if my image is too big or too small. And down here I have the data in more details. Okay, if I resize slowly this page, we see that new images get loaded. And down here, I have a second entry in the table. So when I go on, you will see the transparency slowly changes, the border width slowly changes, it flickers every time when it loads a new one, and here it adds it also to the table. I will do that now slowly for the full page. As you can see, the border changes a little bit. Now it is transparent. That means now it is undersized. We also understand that from the numbers on the right. I slowly go on. And at the end, second one, boom, we jump back. When that is done, you have a full table with all information that you need to debug, and you can adjust basically the numbers and see if the right pixel ratios are loaded and if your image is really in the right size. When I would scroll back again and would rescale here, you would notice that there is not a single of these loading points triggers. That means after the first iteration, the browser, or let's say with every loaded image, the browser decides now on its own what the best resolution is, and normally picks the biggest or best one if it is anyway already on the device. So that's a nice thing that the browser takes it over if you are able to introduce the right numbers and the right settings. Okay. I have the link here, small pixel graphic that shows you some visual reminder what it is, debugging SRC set. The next thing, and this is what I consider the end boss in media optimizations, SVGs. Yeah, everybody loves SVGs. I don't need to explain why they are so good or what different tricks you can do with them or how many bytes you can size with them. I want to straight away go to things that are not able with SVGs and are a little bit of a pain in the ass. A couple of things I will cover here, and I will also share a lib that you can use to cover all of these problems. And the lib that I want to share here is called NGX Fast SVG, and that image solves a couple of different problems. Problem number one, it can lazy load SVGs, and this is not implemented normally in the browser. Browser has no implementation for lazy loading on SVGs, just as I showed you before on images and on iframes. And the second one is there is no cool trick or technology out there that solves hydration, right? I could, if I already have the data on the server, transfer that directly to the client in a smart way, save a lot of DOM nodes and already have my SVGs present on the first contentful paint. So let's first go with the loading. And here you can see on the left side, when I initially load the page, all SVGs are present. And in fact, some of them, the lower one, are only used when I open, or are only visible when I open the side menu here. So why should I load them at the beginning if I only need to load them when the side menu is open? By just placing that library with a one-liner in your code, you would have the following scenario. On the left, you load it, you see 4 images loaded. None of the invisible images are present. And if you open up your side menu, then they drop in and they are lazy loaded. What I want to point out here is this lazy loading is not JavaScript based, like handwritten lazy loading, a re-implementation of the lazy loading of images. No, this leverages the browser's internal implementation and therefore is always in sync with the current implementation. The second thing, and this is a really cool trick, you can server-side render SVGs. If you look here, this is a non-server-side rendered page, and if you open it up, you have a lot of images. If you would turn on server-side rendering, you would have the same images because all of them are SVGs and they are not transferred or anyhow managed on the server side. This library has another one-liner where you can basically have this scenario. You render it on the server and you retrieve a completely empty log. None of the SVGs is fetched on your client side because they are already inlaid on the server and reused. What do I mean with reused? If you have 100 times this circle icon in a SVG graphic, the server uses a special SVG DOM caching mechanism to reuse the DOM nodes, and you basically only have one single icon here present as DOM nodes, and all the others are projections. That's it for the tricks that I have for the LCP part. Now I want to jump to something that will die soon. First input delay. First input delay was a measure, an old measure. I don't want to go in too much details. That is now dead. That covered the interaction after the page was loaded and how fast the browser could react to it. It goes away, and in, I believe, 20 days, if I'm correct, it will get replaced with the new metrics INP, interaction to next paint. This metrics is not only when you bootstrap the application, but can be measured over the full app lifecycle and also is included in Crux data. You can have a 200 milliseconds of blocking scripting time while interaction, and it is still considered as good. The rest is to improve or poor. And I can tell you this new metrics will make a lot of teams struggle because it is the hardest to nail down, the hardest to fix. Sorry. I want to give you more mental model that you can understand what the time INPs really meant. So on the very left, you have a user interaction. You click somewhere, you type somewhere, and that delay already could have, that interaction already could have a delay because some other scripts are currently running, right? So this is the input delay at the very right, left. Then you have the processing time. That is the time that it takes to execute all your JavaScript event listeners, whatever the interaction does. And then you have, again, render and paint. And after this is done, you prompt and promote the next frame. And you present the next frame. This is broken down in a couple of steps. And the processing time here, the yellow part, is most hardest to solve. You can have a couple of lips, like if you do big lists, you can use virtual scrolling and other things. But in the end, when you have solved the biggest part here in the middle, you end up with rendering and paint. And those two measures at the end are the last thing, sometimes dramatically big, that you will really struggle to solve. And I want to show you some across all stacks tricks in CSS, how you can improve the last bit that sometimes is a couple of 100 milliseconds. And in many cases that we fix, this is the lowest hanging fruit because frameworks normally abstract the rest away. So what do we use? We use techniques, rules, properties that are called contain and content visibility. And you can see contain is well supported in a couple of other browsers. And here, a custom table that I created for you in an overview, you can see what you can use it for it. You can basically impact the time it takes to lay out and paint different parts of your page. If you want to dig in, this is the table that you should go to. It tells you in one image everything you need to know. I quickly want to give you more concepts what it does. So the rule that we suggest and use is contain content. It's basically a combination of contain paint and contain layout. On the left side, you see what it will do to your layouting. When you wrap a div with this CSS rule, it will treat all its children as a separate unit. So if you modify one of the children's, it only impacts that sub part of your page and not relayouts the whole page in the browser. On the left side, you have the paint impact, and here you see it also creates a boundary that restricts the paint work only to a specific subset in your page. And people often tell me like, how much improvements you can make. And I have a couple of numbers, especially for those questions here in the slide later on, that I can show you what the real impact in milliseconds is. But before, let me go to the second trick, CSS content visibility. Not that well supported, still a couple of boxes green, but this one has heavy impact. As always, I draw some overviews, everything on one page, the things that you need to know, how to use it, how hard it is to use, what the impact it has here with pluses, more or less, and a couple of other informations if you want to dive into the details. If not, I give you here more concepts. You already understand the first two things, and you see that contain content is at the bottom, and this is equal to content visibility. Those two improvements you gain with content visibility. And on the right, you have the property, the ability of content visibility that is only available on its own, and that is it implements some kind of virtual scrolling in the browser. And if some content is below the screen, it will drop it from the complete render pipeline and save a lot of calculation time. How much I can show you? This is a measurement that I did recently on the next page. If I toggle the dark mode here, and this is a Mac M2 with the strongest chip in, so I still have red squiggles here in the bottom. For a mobile phone, this was a couple of hundreds of milliseconds, close to 800 milliseconds. And at the top, you see that all of them are gone. What did I do? I just applied those two rules, content visibility and contain. I also did it with a couple of other Angular projects here, a massive one, and you see the numbers that we gained. It is incredible. It nearly always halvens the cost. In many other ways, it really dropped it from a couple of hundred milliseconds to zero. Here, another example from Observable HQ, a pretty big data processing page, and we were able to change a couple of lines of CSS and do that improvements here. That is from a 260 milliseconds to 15, a massive improvements just with a couple of lines of CSS. That was a quick walkthrough on the harder parts of how you can do some performance optimizations. I showed you a couple of things in Angular, but the core metrics that I want to encourage again, that you remember, the user-centric metrics is here in a recap. It's CLS, that is the visual stability. It is INP, that is the responsiveness of your page. And it is the LCP measure, that is the loading performance of your page. Let me recap the other tricks that I showed you too. Of course, we talked about Web Vitals and how you improve that, a little bit of more advanced techniques and tools that I use to really get the best out of the different things. We looked at the LCP breakdown, a chart, a methodology that I love to use and reuse. By the way, also included in every Lighthouse audit that you run, but here available as a slide. And there's a very excellent mental model that you can draw to understand the LCP time. I showed you non-trivial things, how to deal with fonts. That is maybe the least supported thing out there. And I showed you the technique of font style matching. We also talked about the hard parts on image loading and how to debug SRC sets. I showed you this code snippet that we open sourced that helps you to debug the different breakpoint sizes. And in the end, it shows you if your intrinsic size and rendered size is correct and if you overfetch or underfetch. Then we talked about image lazy loading. This library is only available for Angular. Of course, there is a lot of abstract theory behind it that would work in other frameworks, but this library is only released for Angular, and it does two things that you can normally not do. It lazy loads your SVGs, and a really key feature, it is also able to hydrate it, and you have a zero fetch rate for all your SVGs, and you can also reuse the DOM nodes. Link is here at the bottom. And we also do a couple of performance audits and performance consultings in your company. If you're interested, ping us. We would love to help you with whatever problems you have. My name is Michael Hladky. I'm very happy that you spent the time with me, and I'm also very happy to answer any questions you have or answer your emails that you sent. Follow me on Twitter, and that's
Yeah. Okay. Okay. In the last version of the Angular, we have a more optimization tool. So, what do you think about this? How we can? So we have already we have tools to improving process with the images and other stuff. So
well in the
maybe in the future we can how we can handle with these optimizations.
So in the last releases from Angular, starting from 15 on, they made a couple of really cool improvements that slowly made now a good impact. But by the way, the examples that I showed you, they still worked with Angular 14 or 13, I believe, I'm not sure, but 14 for sure. And we back then already had the fastest app. But what happened since then is quite exciting. Sorry. I have a little bit of a bad throat. It's quite exciting, and this is that we got a lot of tools that automate all the manual steps that you needed to do. So the ng optimized image initiative driven by the Aurora team, not directly by the Angular team, is really a cool thing. It helps you to do all the lazy loading, all the preloading. In the future, they will ship a couple of more pretty cool features that are also present in other frameworks. They basically try to synchronize tooling across frameworks and stacks, and this is the Angular implementation is one of the implementations out there, and they want to have the same amount of features in best case everywhere. So there are a couple of cool things that still land. Then the Angular team fixed the server-side rendering part. That was pretty exciting. We did not have good numbers, especially with this full deletion of all DOM nodes and executing and redrawing everything in DOM again. That was also fixed already in version 16. Now with 17, we have a couple of more exciting features. It is way easier to lazy load components with the defer directive. It is way more efficient to iterate over lists and to have better approaches also to lazy load services. So that is stuff that is really exciting and helps a lot to like get rid of all the manual work, right? But you will still have to understand always how to approach that problem. What is the problem? In fact, you will not be able to just create a perfect thing out of the box.
Yeah. Oh, okay. It was amazing. Thank you for sharing so much knowledge about optimization. Let's keep pushing the boundaries of the web development together. And that's a wrap for today's NG Meetups with Michael Hladky. We have delved into the world of Angular optimization, explored performance at a scale, and uncovered non-trivial optimization techniques. Thank you very much. Have a nice day.
Bye.
Bye. Bye.
I guess I can share